AI coding agents are getting scary good. Cursor can generate entire features. Claude can build applications. OpenAI agents can autonomously edit repositories. And every week, someone claims software engineers are finished. But here is the strange thing. The best engineering teams in the world are still aggressively hiring senior engineers. Not despite AI, often because of it. Why? Because most people fundamentally misunderstand what senior engineers actually do. Coding was never the hard part, and AI agents are exposing that faster than ever. This video is not anti-AI. Agents are real accelerators. The question is, what work survives when implementation gets cheap, and what work becomes the bottleneck? Watch the agents work in real time. Features scaffolded, repositories edited, pull requests opened with thousands of lines before a human ever reviews the blast radius. Every week, the hype cycle names a new tool and repeats the same headline: software engineers are finished. Cursor, Claude, Copilot, Devin, OpenAI agents. All impressive, none replacing judgment. Coding was never the hard part. That is the thesis, and AI agents are making it impossible to ignore. If you are a senior engineer, tech lead, or founder betting on agents, the next 10 minutes reframe where value actually moves when code generation becomes abundant. Most people think software engineering is about writing code. It is not. Writing code is just the final expression of a much larger decision-making process. Junior engineers live in implementation, syntax, frameworks, getting code to work. Senior engineers live in design, scale, reliability, security, and the constraints nobody puts in the ticket. Junior engineers mostly focus on implementation, syntax, frameworks, and making the code work. Senior engineers operate at an entirely different layer of the stack. Senior engineers optimize for system design, scalability, reliability, maintainability, and security, the layer above the pull request. A senior engineer's real job is reducing future risk, before the incident, before the rewrite, before the compliance audit. AI excels at localized tasks and patterns. It struggles with future consequences across teams, time, and production reality. That is the part AI agents still struggle with badly, not because models are dumb, but because production reality is ambiguous, political, and interconnected. They also carry business constraints and organizational complexity, trade-offs that never appear in a prompt or a greenfield demo repository. AI agents are incredible at generating code patterns, boilerplate, APIs, components, database models, and tests. Honestly, that is amazing. A huge share of development was repetitive anyway. From prompt to pull request, agents compress the path from intent to code. That pipeline is real, and it is getting faster every quarter. But generating code is not the same thing as engineering judgment. The insight is simple. Synthesis is cheap. Deciding what to synthesize is expensive. An AI agent can scaffold authentication in minutes, login handlers, sessions, tokens, while a senior engineer is already modeling tenancy and threat surfaces. Multi-tenant or single-tenant, RBAC, enterprise, SSO, audit logging, compliance, data residency. Seniors ask these on day one, not after the breach. Generate code is not the same as engineer systems. Synthesis is cheap. Deciding what to synthesize is expensive. The difficult part is not building authentication. The difficult part is understanding the consequences of architectural decisions over months and years of change. AI agents are very good at solving localized problems, But production systems are not localized. They are interconnected graphs of services, teams, dependencies, and hidden edge cases. Production is a graph: APIs, services, data stores, queues, not a single file an agent can fix in isolation. Ambiguous requirements, legacy infra, hidden dependencies, org politics, scaling bottlenecks. This is where agents collapse, not on syntax. Software engineering is trade-offs, constraints, compromises, priorities, not a single correct answer the model can retrieve. AI optimizes for, does this code work? Seniors optimize for, will this system survive change? That is a completely different optimization target. Retry loops, latency spikes, schema drift blocking rollback. The incident room is where localized fixes meet global failure. That is a completely different problem. And it is the problem senior engineers are paid to hold in their heads when everyone else is celebrating the green CI check. This is where AI agents begin collapsing, not on syntax, but on trade-offs. There is rarely a correct solution, only constraints, compromises, and priorities. Real-world systems involve ambiguous requirements, conflicting business priorities, legacy infrastructure, organizational politics, unreliable dependencies, and edge cases nobody documented. The higher you go in engineering, the less your value comes from writing code, and the more it comes from decision-making, prioritization, architecture, communication, and system evolution. From user intent through architecture, reliability, operations, and team velocity. Seniors design the stack, others will live inside for years. Technical debt, migration paths, operational complexity, failure recovery, developer velocity. The whiteboard questions that outlive any single sprint. As you climb the ladder, judgment dominates typing. Architecture, communication, and risk reduction become the product. Senior engineers reduce catastrophic mistakes before they ship. That is what elite compensation is buying. 18-month thinking is not pessimism. It is how you avoid shipping a system your team cannot safely change next quarter. Great engineers do not just build systems. They build systems other engineers can safely evolve, with clear boundaries, observable behavior, and recoverable failure modes. That is why companies still pay massive salaries for elite engineering talent. Not because they type faster, but because they reduce catastrophic mistakes before they ship. Ironically, AI might actually make senior engineers more valuable. When code generation becomes cheap, architecture becomes the bottleneck, not the keyboard. Prompt, tools, memory, evals. The harness around the model is where production behavior is actually defined. More code, more integrations, more agents, more infrastructure. Cheap generation does not reduce complexity, it often accelerates it. System boundaries, governance, observability, orchestration, reliability engineering. The scarce skills when anyone can generate a PR. Cheap code on one side, expensive judgment on the other, senior leverage lives in the overlap. We are entering a world where one engineer can generate massive amounts of code extremely quickly, which creates a new problem: uncontrolled complexity explosion. The engineering stack is shifting upward, less manual coding, more systems thinking. Implementation compresses, judgment expands. Architecture reviews, not autocomplete sessions, become the schedule bottleneck when code is free, but coherence is not. Now this does create a real challenge. Junior engineering work is exactly the layer AI automates best: boilerplate, small features, refactoring, and documentation. The old path, learn by writing lots of code manually. The new path learned systems thinking earlier, because agents absorb the typing layer. From code writer to system operator, reviewing, integrating, and constraining agent-generated systems safely. System operator, not typist. That is the career identity shift junior engineers need to plan for now. The traditional path from junior to senior may fundamentally change. If AI handles most implementation, companies may expect engineers to develop systems thinking much earlier. The future engineer might look less like a code writer and more like a system operator, reviewing, integrating, constraining, and evolving agent-generated systems safely. AI coding agents are absolutely changing software engineering, but not in the way most people think. They are not replacing engineering, they are compressing implementation. The future belongs to engineers who understand systems, architecture, orchestration, governance, and long-term complexity. Because coding was never the hard part. Managing change was. And that is still one of the hardest problems in technology. Agents help you type. Seniors help you survive.